Intensity is a really big number. So what we're going to work on is relative intensity. And relative intensity is a ratio between the intensity or the loudness of the sound we're listening to and threshold intensity. And that helps because then we're dealing with two numbers, both of which are relatively big or relatively small, depending on our point of view. It still doesn't help us. So Alexander Bell came along and came up with a log scale of relative intensity, and the equation that we use to find it is the decibel equation. So decibel units are lowercase d, capital B. Those are the units. The symbol is a Greek letter beta. And the equation looks like this. Decibels, or beta, equals 10 times the log of the relative intensity. You're told something has a certain decibel level. This is where the number comes from. This is the equation we're going to use. Again, this is an equation you might want to jot down because we're going to be using it very shortly to do some calculations. If we take a look at a variety of common objects, we can take a look at how their decibel ratings compare. If we start down at the low end, the faintest sound that you can hear has a decibel value of 0. So that is at the threshold intensity, so that's I sub 0. Whispers have a decibel reading of about 15. Rustling leaves, a little bit louder. Average home, average classroom, it's about 50. On Thursday, I'll bring out the decibel meter and we can take some readings while we're doing whiteboarding and see how loud things get here. Vacuum cleaners, other implements like that that have motors are about 75 decibels. The commons during lunch. Restaurants, about 80 decibels. In general, OSHA has determined that if you are subjected to levels of more than 80 decibels for longer periods than an hour, if you want to protect your hearing, then you should be wearing hearing protectors. And just putting earbuds in isn't going to protect you from outside noise. What you end up having to do is crank the music up louder to drown out the background noise, and that just increases the damage to your hearing. Power mowers, weed whackers, other kinds of tools like that, 100 decibels. If you're standing outside an airport near the takeoff runways and you hear jets taking off, especially if you're kind of behind them, those can be up to about 150 decibels. Our fire alarm, especially if you're in the hallway by exit 17. I've taken the decibel meter out a couple of times when we've gone out, and it's about 117 decibels. I don't have a frequency meter, so I don't know what the frequency is, but they tend to pick the frequency between that low level between 2,000 and 5,000 hertz, where you don't need a lot of intensity to make it really annoying and painful. Okay, let's take out your practice problems sheet and let's work through a couple of the decimal problems, and then you can have some time to work on worksheet 1. So look at the first question. We've got a car stereo and it has an output of 75 watts. Speakers are in the back of your car, or they're 1.25 meters from your head. We want to find out what is the intensity of the sound you experience. So we're looking for I. First we have watts and we have a distance. So that's a radius. Remember, sound waves travel as expanding spheres. So that 1.25 meters is the distance from the sound source, and so that's going to be the radius of your sphere. So if I want the intensity, I'm going to use the equation watts over surface area. So I have 75 watts, and my surface area is the area of a sphere, so it's 4 times pi times the radius squared. And you should pause this, take a few minutes, figure it out, and then when people have it figured out, start it back up and we'll take a look at the answer. Hopefully you got an answer close to 3.82 watts per meter squared. So that's not that big a number. Let's take a look at what the decibel value is. So we're going to use the decibel equation. So we're going to do 10 times the log of I over I0. We just found I, so that's 3.82. And I0 is our threshold of intensity, so that's 1.0 times 10 to the negative 12. So we're going to take the log of that and then multiply it by 10. Again, pause this, calculate it, and let's compare what you get with what the answer is. Hopefully what you found is you get 125.8 decibels. Okay, we're getting close to danger zone or threshold of pain. So what that means, if you've got your speakers cranked up full blast, especially if you have the windows closed, you're going to be rattling your car and pounding on your poor eardrums. Let's take a look at the next problem. Your car alarm, if you have one, goes off and it produces a 92 decibel sound. And now we're looking for the intensity ratio. That's I over I0. So this time I'm going to start with the decibel equation and work my way backwards. So decibels equals 10 times the log of I over I0. So then I'm going to put numbers in. I have 92 decibels equals 10 times the log of I over I0. That's what we're looking for. So how am I going to figure this out? First thing I probably want to do is divide both sides by 10. So I have 9.2 equals the log of I over I0. So now I'm just going to take the inverse log, which is simply raising each side to the power of 10. So we'll say 10 to the 9.2 equals I over I0. And plug 10 to the 9.2 power into your calculator, and hopefully you get 1.58 times 10 to the 9th. Okay, that's my intensity ratio. So I'm looking for power in this next question. I start with the ratio of intensities. I need to get to plain old intensity, and that will get me to power. So I over I0 equals 1.58 times 10 to the 9th. And that equals the intensity, which is what I want, over 1.0 times 10 to the negative 12. So if I multiply both sides by 1 times 10 to the negative 12, I get 1.58 times 10 to the negative 3, and my units for this are watts per meter squared. Now I'm looking for watts, and I know that my radius is 2.20 meters. So that means my surface area is 4 times pi times radius squared, and I get a surface area of 60.8 meters squared. So I put that into my equation. I get 1.58 times 10 to the negative 3 equals watts over 60.8 meters squared. And my power rating then is not very big. It's 9.6 times 10 to the negative 2, or 0.096. We'll go 1 watts. So even though it's making kind of a loud noise, it's not a very powerful alarm. All right, the next one, looking at your cell phone going off during class, you get a 52 decibel sound. Power rating is given. You're supposed to figure out how far away is the teacher that heard it. So, same idea. I'll let you figure it out. Pause this, set it up, go through the calculations, and then you get started up and see how you did compared to the way to set it up and solve it. So hopefully you came close to 3.01 meters for the distance away the teacher was when your phone went off. Not a good thing. What I'd like you to do for the rest of the period is you can work on worksheet 1, or you can work on any calculations that you need for your lab. The graphs are on the handout shelf, so make sure you grab the correct class graph. Look in the little box where the slope and y-intercept are. It identifies the period. What we'll do tomorrow is we'll talk about any error sources for the lab. We'll talk about these, and we'll whiteboard worksheet 1. So good luck with finishing up your worksheet, and I will see you on Thursday.